Summarizing quantitative data, min, max, and typical or central values. Numerical summaries. Instead of a histogram, we can also work with the data to calculate numerical values. The next step might be to locate a more precise description of characteristics, such as the smallest or largest value. In StatCrunch, we can obtain the basic descriptive statistics using the commands stat, summary stats, column, and left click. Under select columns, left click on weight, and it should appear in the right box at the top, and click compute. This is using the auto weight data. The following table is produced. Note you can add to this list or omit some of the results by holding down the Control key and left clicking the values you want displayed in the statistics box in the middle of the window. For now, let's just focus on the summary from the histogram. We can update it by telling that the lightest automobile weighed 2,750 pounds, the min for minimum, and the heaviest automobile weighed 6,000 pounds, max for maximum. Also notice N is given. The letter N typically represents the sample size, or how many observations were collected and analyzed in an experiment or study. N is given as 80. Now consider the next question about typical values. What is the most typical weight, or what is the center of the weights for automobiles? This leads to a discussion of the two most common ways to describe the middle or the center. One, the mean, represented as y bar, is defined as the sum of all the data values divided by the sample size n. This is what most people call the average, but the term average can mean different things in math or statistics. The mean for our data would be the sum of the weights for the 80 automobiles divided by 80. We write y bar equals 4,104.6875 pounds. In words, we would say the mean weight for the 80 automobiles is 4,104.7 pounds, rounded off to the 10th digit. The median is another common measure of the middle of a data set. The median is found by first putting the data in ascending order and then finding the middle value. If n is odd, the middle value is one of the data values. If n is even, the middle value is the mean of the middle two values in your ascending list. Notice that the median will always be a value such that at least 50% or half of the values in the data set will be smaller or equal to it, and at least 50% or half of the values will be larger or equal to it. In this example, we would put the weights of all the vehicles in ascending order, find the middle two weights from that list, and then add those together and divide by 2. That would give us a value of 4,000 pounds. The median weight for the 80 automobiles is 4,000 pounds. So why are there two ways, the mean and the median, to describe the center or middle value for data? Well, in symmetric histograms, or data sets, the mean and the median are estimating the same location or the same thing. The mean is preferred as the statistic to describe the typical value when data are symmetric. It just has nicer math properties. When data are skewed, or just non-symmetric in nature, then the mean can be greatly impacted by this feature. The median is not as directly impacted and always has 50% of values below or equal to it and 50% of values above or equal to it. For non-symmetric histograms of data, the median is preferred as the measure of center. You can think of the mean as the location of the balancing point for data in a histogram. If the histogram bars were cut from a block of wood, for example, if we cut that histogram out of a block of wood and try to balance it on the point of a nail, the mean is that balance point location. The vertical green line locates the mean in this histogram. The median is the location where half the area is to the left and half is to the right. If you were to paint the block of wood orange and purple, starting with orange until you got half of the surface painted and then switching to purple, where do the colors change? The vertical red line is where the colors change and locates the median in this histogram. Another example. Consider the amounts of time played by starters of men's college basketball teams in Division I between the 2008-2009 and 2012-2013 seasons. A histogram is given below which shows a skew to the left shape. The statistics were calculated and the mean was 27.9 minutes, while the median was 29.0 minutes. This further shows that the mean is smaller than the median in this skew to the left data set. We will come back and talk about how much of a difference is needed to say that the mean and the median are really different values and thus should indicate skewness in a histogram after we talk about variability.